and welcome to the 28th video lecture of Quantitative Techniques, Semester 3, Module number 2. In today's video lecture, we are going to start with where we had left off in a previous video lecture, that is some simple problems on probability. I hope you have understood the previous problems which I had discussed in our previous video. If you have not understood, please ask me and you can always call me. So let us start with today's video lecture. So yesterday we had taken problems on dice, problems on coins. Today we shall take problems on dice. Dice has 6 faces, as we have seen. 6 faces are numbered 1, 2, 3, 4, 5, 6. When you roll one dice at a time, you will get either of these 6 numbers, that is 1, 2, 3, 4, 5 or 6, which is your sample space. So let us take problem. A fair dice is rolled once. Okay, so what is the probability that the number that we get is an even number that they have asked? That is, they have asked what is the probability that the number that we get on the top is an even number. So what is the experiment here? Experiment, what is the we are doing is rolling of a dice. Then the sample space that is there is 1 2 3 4 5 6. S is equals to 1 2 3 4 5 6. So what is n of s equal to? Whenever we roll one dice, we get this sample space only, that is 1 2 3 4 5 6. Is there any other possibility? That is, suppose if we are rolling a dice, so the dice is rolled once. So what are the outcomes possible? Either we will get 1, 2, 3, 4, 5 or 6. So this is the sample space 1, 2, 3, 4, 5, 6. So these are the possible outcomes and hence it is the sample space. We are not going to get any other outcome. So it contains all the possible outcomes of the experiment. So what is your n of s? That is number of items in the sample space. If we count the number of items, we will get 6 number of items in the sample space. Now the event A that we are interested in is even number. They have asked us what is the possibility, what is the probability that an even number comes up. So an even number. Now let's concentrate on our sample space. If we concentrate on the sample space, let's concentrate on the sample space here. Out of this, how many numbers are even? Those even numbers will come in this set. So 2, 4 and 6. So any other number left out which is even? No. So set A consists of 3 numbers 2, 4 and 6. So n of A is equals to 3. Okay, so what is probability of A? Probability of A, the formula is probability of A is equals to probability n of A upon n of S, which is equals to 3 upon 6. N of A is 3, n of S is 6. So 3 upon 6, that is 1 upon 2, 3 ones are 3 twos are. Okay, so it becomes 1 upon 2, so which is equals to 0.5. You can either keep it as fraction 1 upon 2 or you can also keep it as decimals 0.5. Your answer should always be between 0 and 1. It should be a positive answer only, then only it is right. So I hope you understood this problem. Let's move to the next problem. This was a simple problem. The next problem, combination problem, we have I've taken. Only one of this may be asked for your 2 marks questions. That is, I've asked 5 things. Out of these 5 things, only one will be asked if it comes for 2 mark section. If it comes for 5 mark section, then 4 or 5 things can be asked. So let us take that problem. A fair dice is rolled once. What is the probability that the number which turns up is A, a odd number, B, a prime number, C, a perfect square, D, a multiple of 5 and E, 6. So there are 5 things that have been asked here. Odd number, the first one. As I've told you, some of this explanation of these numbers I've sent you on WhatsApp group. What is a odd number, what is a even number, what are natural numbers, what are whole numbers, what are integers, what are prime numbers. All these explanations I've sent you in your WhatsApp group. You have to read it before you see this video. So what is an odd number? Everything except the definition I've given you. Then we'll take this problem. Experiment. What is the experiment here? Is rolling of a dice. A dice is rolled once. So the sample space remains same. What are the possible outcomes when you roll a dice? It is either 1, 2, 3, 4, 5, 6. So one of these 6 outcomes you will get, and hence n of s is equal to 6. Fine. So once you get n of s is equals to 6, let's move ahead. Now let's move experiment wise. The first experiment is, first event that we are interested in is, it is an odd number. So let's write it. Event A. So A, event A, it is an odd number. Okay. So it is similar to the one example that we have done previously, that is an even number we have taken. Now the question comes of odd number. What is the sample space? Sample space we have got in our previous problem. It is equal to 1, 2, 3, 4, 5, 6. So this is the sample space. Out of these, this is 1. Okay. So how many are odd numbers? 1, 3 and 5. So these three things will come here. A equal to 1, 3 and 5. So what is n of a equal to? It is equal to 3. So p of a is equals to 3 n of a upon n of s. So n of a is nothing but 3 divided by n of s is 6. So 3 divided by 6 is 1 upon 2, which is equals to 0.5. Okay. This was similar to the previous problem which we have solved. In the previous problem we have taken n of even numbers. Here we have taken odd numbers. So let's move ahead. Remember, n of s is 6 and that remains same for all entire this problems. So n of s, we know that it is 6. So no need to write sample space again and again. B, prime number. Now how many prime numbers were there in 1, 2, 3, 4, 5, 6? 1 is not a prime number, 2 is a prime number, so that will come here. 3 is a prime number, it will come here. 4 is not a prime number, 5 is a prime number, it will come here. 6 is not a prime number. So out of 1, 2, 3, 4, 5, 6, only 3 numbers are prime number, that is 2, 3 and 5, and hence n of b is equals to 3. Okay, number of items in set B. So what is probability of B? Probability of B is equals to n of B upon n of S, which is equals to 3 upon 6, which is equals to 1 upon 2, 3 ones are and 3 2s are. So it is 1 upon 2, it is equal to 0.5. Okay. Let's move to the next sub problem. Perfect square. So what are perfect squares first? Perfect squares are 1 into 1. So first number is 1. So 1 square is 1 into 1, that is 1. So 1 is a perfect square. The next number in natural numbers is 2. So the perfect square is 2 into 2 is 4. So 4 is a perfect square. The next number is 3. 3 into 3 is 9. The next perfect square is 9. So perfect square numbers we are getting 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225 and so on. So this way perfect square numbers will be going on. That is, a number multiplied by the same number is, you will give you a perfect square, and when you find the square root of this number you will get a natural number. Okay. So perfect squares out of these numbers, that is 1, 2, 3, 4, 5, 6. I'll just note down those numbers which I had got. 1, 2, 3, 4, 5, 6. So out of these numbers, 1 is a perfect square, 2 is not a perfect square, 3 is not a perfect square, 4 is a perfect square. So only these two numbers are perfect squares. They will fall in set B, set C. So Set C comprises of two numbers which are perfect squares, so they are 1 and 4. Okay, so n of C is equals to 2. Probability of C is equal to n of C upon n of S, which is equals to n of C is 2, I've got here, n of S is 6, we have found it. N of S remains 6 for this because 1 2 3 4 5 6 number of items in the sample space, that remains same for the entire problem. So 2 upon 6, which is equals to 1 upon 3, that is nothing but 0.33333. It goes on, you can write up to 2 or 3 decimal places. Fine. Next problem, D, multiple of 5. Now multiple of 5, what do you mean by multiple of 5? It should be multiplied by 5, that is it should come in 5's table. Okay, so 5 ones are 5, so 5 is a multiple of 5. 5 twos are 10, 10 is a multiple of 5. 5 threes are 15, 15 is a multiple of 5. 5 fours are 20, 20 is a multiple of 5. Similar 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So all these are multiple of 5's and it goes on. So in 1, 2, 3, 4, 5, 6, that is our sample space, how many multiples of 5 you will get? Only one multiple of 5 you will get, that is 5. So n of D is equal to 1. Probability of D is nothing but n of D upon n of S, which is equal to 1 upon 6, because n of D is 1 and n of S is 6 for the entire problem. We have found out sample space, that is 1 2 3 4 5 6 number of items in the sample space. So probability of D is, when you calculate this, you will get 1.666666 and probably at the end you will get 7. So 2 or 3 decimal places is enough. You can either write 1.6666 or you can write 1.67, sorry 0.167. So this is your fourth. And lastly, they have actually given here, what they have given is the number that turns up is 6. So they have given the actual number here, instead of saying it is a even number, it is a odd number, it is a prime number, a multiple of 5, they have given actual number. So it is 6. So how many numbers are there which are 6, that is which is equal to 6 in the sample space? Only one number, that is exactly equal to 6. So write that number. N of E is equals to 1. So what is probability of E? Probability of E is equals to n of E upon n of S, which is equals to 1 upon 6, because n of E is 1 and n of S is 6 here continuously. So 1 upon 6, which is equals to 0.167. Now if you have not understood this, why n of S E is equals to 1, see here, what was the sample space? 1 2 3 4 5 6. So out of these 6 numbers, how many items are there? How many items are there which are equal to 6? Only one item. Okay, so that item will come in set E here. So n of E is equals to 1. Fine. So this is about this problem. So with this we'll stop for today here. If you have any difficulties, you can always contact me